Hello everyone, welcome back to Nature by Design. So in our second tutorial, we're going to do a quick recap on what we demonstrated in our very first video, how to import those DEM raster layers in our QGIS file. So let's bring our reference map up again. And let's zoom in to around our site. Around Longdale, South Australia. So our site is a heavily industrial area with two creeks on respectively north and south side. So now we're going to double click the base map to reduce the transparency and the saturation to make that more muted. If you are not familiar with how to visualize the layers and change the layer properties, feel free to go back to our very first tutorial. Let's reopen our already downloaded 50 centimeter raster layer. So this time we're going to click add layers and go to raster and click those three dots and find our file 50 centimeter DM model and hit open. So this is imported as a zip file, and when you hit add, QGIS is going to recognize that automatically for you. And in here we can select all layers and hit add layers and hit OK. And after a short bit, all the rest of the layers are brought up to our interface. And we talked about those separate layers are really hard to manipulate one by one. So we're going to go to raster on the top panel and go to miscellaneous and merge all the raster layers. So we're going to select all the raster layers for the input except for our basic map layer and now hit run. Once the algorithm is finished, we close the window and we can see all the separate layer has been merged into one whole layer. So this is much more easier to manipulate. So in the last tutorial, we looked into how to transform this layer into a hill-shaped layer and give it some aspects and slope to analyze the terrain. And in this one, we're going to proceed into generating a set of contour line based on our merged digital elevation model. So in our processing tool, we're going to type contour, and on the GDO raster extraction, we're going to find this contour command here and click on that. So the layer we're going to work on to generate this contour line is the merged DEM layer, not the base mapping layer, which is the ISM standard layer. So we're going to make sure we select the right layer to keep working. And for the interval between contour lines, it is a very important value. We all know how the contour lines are working is we set a distance in between all the lines, and the density of the contour line would just represent the slope and terrain condition of different regions. And now we have 10 point for the interval here. I'm quite happy with that. And let's change the attribute name to elevation, just for future reference. And if we scroll down, feel free to save your contour file to your computer. So next time when you work with the contour, we don't have to generate it again. You can just import your contour file into a QGIS working file. But for me, I'm going to save to a temporary file. And we hit run. So now the algorithm is completed, let's close the window. And this is the whole series of contour line we just generated. You can see here, like the closer contour line represent the cliff right next to the coastline, and we have these industrial plants here with different heights and elevations. Also, when we pan through the map and see the creek here is just show you all the contour lines surrounding the ridges and the water body, and the lowest point also on this creek as well. And now let's do a really fun experiment. Let's generate another contour line. Let's try change the interval to a smaller number. Let's try 5. And also we're going to name it elevation 5. And I'm going to save it to a temporary file again and hit run. So this time when we reduce the interval to a smaller number, it means we're going to generate more contour lines, make the contour look more detailed. Depends on what kind of scale you're going to work with. You can choose either a larger interval or a smaller interval. This operation is going to take more time as we're generating more lines, so we want to be patient on it. So now our algorithm is finished again. Let's close the window. And now you can see in between our previous interval, we have another set of contour lines generated in between any two old contour lines. It means it gives you a more in-depth analysis of the terrain. Based on what scale you're going to work on, you can choose either 10 point for interval or 5 point, depends on how much detail you want to show on your map. So now I want to show more detail, so I'm going to turn off my old set of contour and use the 5 interval contour. And if you double click on your contour layer, you can see a label icon here, and if we change that to single label, it's going to show you all the contour level, like all the elevation levels. And this is another way for us to make sure our interval is workable for our site, for our chosen scale. You can also change the line into a black line, and let's change the width to a really thin hairline. So on your base map, your contour line is not clashing with the layer on the top of it. And let's hit apply, and okay. Let's turn the merge layer off as well. So now we can see all these small numbers representing the elevations of each contour line. If you look closer, you can see the spacing between each line, and if you're happy about that, you can turn it off and apply. Okay. So now we can also feel free to delete all our separate raster layers. Let's remove all the layers. All right. So now the contour line and base map are ready to use as base information for our terrain analysis. And the second topic of this tutorial is to generate points of different elevation levels based on our raster layer. So let's turn the merge raster layer on again and turn the contours off for now. As we mentioned in the very first video, how the raster layer is working is it's made up by millions of pixels. For example, if we zoom into the raster layer, we can see very vaguely it's made up by those little squares of 50 centimeters by 50 centimeters. Now we're going to work on extracting the points in the center of each pixel. And these points will represent the height level, which is the elevation level. We can also call it Z level of each pixel. And then we're going to explore exporting those points and import them into Rhino and try to model the terrain. Before we jump into extracting the point, we want to double check the property of the merged DEM layer. So we right click on merge DEM and click on property. And this menu is going to give you all the information about our merge layer, including the information provider and a dimension of the whole raster layer, including the pixel size. So at the moment, the pixel size is 0.5 meters by 0.5 meter, which is 50 centimeter. That's the size when we imported to QGIS to reach that detail mapping purpose. But now, if you also see the dimension of the whole raster layer, the x-axis is and y-axis are 16,000. It means our pixel amount is double the dimension of the raster layer, if that makes sense. So that will just give us millions of points to extract, which will probably crash our computer and also just make the whole process last for ages. So we don't want that. The one way to adjust that and avoid our computer to crash is to type in, for example, in our processing toolbox, and we find our grass tool, and under our grass tool there's a command called raster resample. Now we can double click on that, and we want to resample the merge DEM layer, which has too many pixels. And now in this GraphJS region cell size, you can type in your ideal size, like 200 or 100. So your pixel size can change from 50 centimeter to 100 meters. That's going to be a drastic drop of size. So that's one way. And another way is to go back to Elvis. So previously, the model we are working on is the 50 centimeter DM model, and we can scroll down to here. So this one, Geoscience Australia, is providing all sort of different size of raster layer, but that's shown the similar information just in a lower resolution. We can try to select the smooth version or the hydrological version and click download again. And after I downloaded my smooth version of DEM and import it to my QGIS, and let's bring them on. So as you can see, if you zoom in, the resolution is much more lower than the previous file, but that's actually helpful for us to define the new amount of pixels. So now you can see if we grab the measure tool and measure from here to there, and the new pixel size is going to be about 25 meters, which is much easier for us to extract point. So now I'm going to just use the hydro enforced 1 second DM to extract point. And let's go back to the processing toolbox and type in raster pixel to point. So now the layer we're going to work on is changed to hydro enforced, and we can call the value name Z. So all the points we're extracting now is given a Z value, which is the elevation value. And I'm going to save that to a temporary file, and let's hit run. So now you can see there's a new layer being generated called vector point, and let's move that to the top. And here you can see all the points were generated in the very center of each pixel. That's exactly what we want to see. And if you right click on the vector point and go to attribute table, you can see the value of those points. So we gave Z value to those points, and on the ocean level, the Z value is of course the sea level, which is 0. And you can see the different numbers, different values appearing here, which are representing the various elevation on the terrain. And now we have the Z value of those points. We also want to give them the X and Y value, which is the coordinates and the location. So back to processing toolbox, we're going to type in XY. We can find this add XY field to layer. We double click on that. The layer we want to give the XY value is the vector point that we just generated. So that's the layer we're going to choose for the input layer. You can change the coordinate system to match our main coordinate system. For the field prefix value, I'm going to type in XY and also create a temporary layer and hit run. So now you can see just generated a new set of point with the red color on top of the purple Z value points we just generated. So the same thing is we right click on the added field layer and go to attribute table. So now you can see instead of only showing the Z value, all the points are assigned with an X and a Y value just to give them the completed three-dimensional value, including location and elevation. So we're happy about that. And next step, we're going to export those points. Let's right click on Edit Field and click Export, Save Feature. So we want to save that as a comma separated value, which can be opened in our Excel as an Excel sheet. I'm going to give it a file name. Let's call that demo point XYZ. I'm going to change that CRS value and I'm going to save that to my desktop again. Save and hit OK. So our layer has been successfully exported to my desktop. I'm gonna have a look on my desktop and try to open it. So we find our exported points here and I'm gonna open that with an Excel sheet. So now you can see all the numbers in the attribute table has been laid out in a Excel file. Now we just want to rename the X value as X and Y value as Y. And we're going to move the Z value all the way to the very end of it. So that's the right order, and can just delete the whole column here. So now we have the proper XYZ value for all the points that we extracted. I'm going to save that and close it. In the next step, we're going to jump into Rhino, and you might be familiar with the Rhino interface. So we can select new model, and here be our Rhino work interface. So we noticed that the units on the very bottom here is millimeters right now, but we want to change that to meters. It's just going to be easier for us to operate the model because the raster layer we just used to extract the points is with each pixels of 25 meters to 25 meters. So we're going to go to settings now and click on units. I'm going to change that to meters here. Say yes to rescale the model. Now the unit has been successfully changed to meters. Now we can export our CSV file that we just saved. So we can drag that directly into our Rhino interface and click on import file, hit apply. I'm going to select comma because that Excel file is comma separated, and we can click on create point cloud and select import. So now our file has been successfully imported. We can select all, Control and A, and click on zoom extend, and now it just brings us to the series of points or the point cloud we just imported. So also if you go to perspective, you can just rotate the model around, and now you can see the ridges on the north of our mapping and another creek on the south side. So now we want to launch Grasshopper. And open a simple interface. Next slide. Delete all of that. And now to assign this point to a point component, we want to double click on Grasshopper interface and type in point. And now we select the point component here. And the command we want to use to generate the terrain based on this point is called Adelaide Mesh. It's basically transforming our point layout into a mesh surface, and then we can consolidate the surface and just transform that in a poly surface if you want. And for the point, we want to explode our point cloud first, just to make them as individual points. Now they are separate points, and we right click on the point component and we select set multiple point. And in our Rhino interface, we want to select all the points that we just exploded. Now you can see the component has changed color to green. That means our point has been successfully assigned to the component. And now we want to connect the point component to the point input in our Adelaide Mesh command. By doing that, all our component turned grey. It means the operation has been completed. And we want to right click on Adelaide Mesh and click on Bake. And we can assign a layer for the surface. And now I also want to disable the point layer. So from the top view, we can see a new mesh shown in red color. It has been generated based on the 3-dimension value of those points. We can also deselect all the points and go to perspective view. I'm going to change the color of that. So if you rotate the model around, you can clearly see all the shades and elevated terrain, and also the lower part of terrain, including the jetty here, showing the meshed surface. And now to operate our mesh, we want to use a tool called Mesh to Nerve, which is transforming our mesh layer to a poly surface layer. So we want to select our polygon meshes and enter. So now we have a new poly surface layer being generated based on the mesh layer, and let's move that to layer 2. Okay. Let's change it to black as well. Now if we right click on perspective, the perspective tag here, and set our view to or rendered. And you can see we just generated a new layer of workable surface in Rhino. Now you can use this as your base layer, your base terrain layer, to model your intervention on your site at your chosen scale. So this is how we extract the point from QGIS and model terrain in Rhino. I hope you find that helpful. I'll see you in the next one.